today we're going to be looking at proving that angles are congruent. Oh, I also need your bell ringers. Thank you. Did not get them. Or did I get them? I just didn't get yours. Anyone else bell ringer? So to start off, we have some theorems. So we've learned about postulates, definitions, and properties as reasons we can use in a proof. Now we're going to add in what are called theorems. They have also been proven to be true. I won't show you the proof for each one because it would take a long time. But these are kind of like postulates in that we accept them to be true, but there is a proof behind it as to why it is true. And we did look at vertical angles before. Remember, the definition of vertical angles was opposite angles formed by opposite rays, I think was the formal definition. I liked to say that they were opposite angles formed by intersecting lines, was the definition I prefer over our textbook's definition. Because these look like intersecting lines, I don't think of them as being rays, intersecting opposite rays. So remember, angle 1 and angle 2 would be vertical, and angle 3 and angle 4 are vertical. When I taught this to you, I told you they're congruent. We proved it with numbers. If you remember, I said, let's say this is 150. Well, if this is 150, these two together are supplementary, right? So how big would angle 3 have to be? How many degrees would angle 3 have to be? Brett? 30 degrees. Then angle 3 and angle 2 are supplementary. So if this is 30, 180 minus 30 would get me 150. And then 2 and 4 are supplementary, so 180 minus 150 would get me 30. So you can do a little numerical proof showing why these are congruent. The vertical angles theorem just literally states that exactly. Vertical angles are congruent. Now when you use this in a proof, which we will below, you can either write the theorem. Some students just like to write the content of the theorem, which I'm fine with. So if you just want to write vertical angles are congruent, we'll abbreviate that even, VA are congruent, you can. If you would like to write the vertical angles theorem, you can, whichever you prefer. So we can see angle 1 was congruent to angle 2 because those were opposite and vertical, and 3 is congruent to 4. All right, the congruent supplements theorem and the congruent complements theorem. We don't use these theorems very often, but they're in our book, so I share them with you. Remember, supplements mean that they are two angles that add to 180. We usually say supplementary, but supplements would be the same thing. They supplement each other. Two angles are supplements of the same angle or of congruent angles. So for example, we see that these angles are marked congruent. Do you see how angle 2 is the supplement of this one, and angle 1 is the supplement of this one? So because they're both supplements of a congruent pair of angle, that means that angle 1 and 2 also have to be congruent. So for example, using numbers, if this were 50 and this were 50, we would again know that 180 minus 50 is 130, and 180 minus 50 is 130. So you can see numerically that they would be congruent. So if two angles are supplements of the same angle, then those supplements are also congruent. The next one says if two angles are complements, which remember complements means that they sum to 90, of the same angle or of congruence, then the two angles themselves are congruent. So let's suppose angle 1 is 20 degrees, which would make this angle in the middle 70 degrees, because we see a right angle symbol here, so 20 plus 70 gets me 90. And then if this one is 70, see how there's a right angle among these two angles, that means that this one would have to be 20. So because these two angles are complements of the same angle, then the two angles themselves are congruent. Again, we don't use these very often. They kind of actually seem like common sense when you plug numbers in, but I share them with you. Theorem 2.4 sounds like common sense, but it is a theorem, and you actually will use this one in proofs. All right angles are congruent. It will save you time from stating that an angle is a right angle, stating that it equals 90, stating that the other angle is a right angle and equals 90, and then using substitution to put them together. we will just see if we see two right angles, we can say they're congruent because we know all right angles are congruent. So it'll save you time in a proof. Put a star next to this one. And the first one, actually. Those are the ones we're going to use the most often from this set. The last one is theorem 2-5, which says if two angles are congruent and supplementary, then each is a right angle. So if they're congruent angles and they add to 180, they have to be 90 plus 90. Those are the only two numbers. Now this is the only one that has a name. All the other ones have numbers. I don't want you to memorize the numbers because if you were to go to a different textbook, it may have a different number in it. So for this one, when we use it in a proof, we will just write out what it means. That's why usually up here I just write out what it means. But if you prefer to write out vertical angles theorem since it has a name associated with it, you can. All right, let's look at just some examples solving for x and angle measurements. And first of all, on your note sheet, I don't think this copied very well. That is a plus sign, 3x plus 35. I think it kind of looks like a minus. Find the value of x. So the first thing you want to notice are we have these two angles. What type of angles are these? They're vertical angles. And we know vertical angles are congruent. We know that the definition of congruent angles is that they're equal, right? So because these are both congruent, I can set their measures equal. 4x equals 3x plus 35. Solve for x. X is 35. Then they ask us to find the measure of each angle. So I'm going to take 35 and plug it back in. I should get the same number, do I? How many degrees would each angle be? Yeah.
140.
Good. 140. And this also gets me 140. If you would plug it back in and get different answers, you solved it wrong, so always double check that. Find the measures of the other pair of vertical angles. So how big would these angles have to be? There's no numbers or variables on them. But we can use the fact that each one of the other pairs is 140. Cal?
40.
Good. Remember, when you see a straight line is 180 degrees, which indicates that these two angles are supplementary. So 180 minus 140 would get me 40. You could also look at it this way or this way. There's lots of different pairs. So each of those will be 40. Check to see that the adjacent, which means next to, angles are supplementary. So 40 plus 140 is 180. Yes, yes, and yes. Now, the next one is a completely blank proof. And we are going to use the vertical angles theorem to solve this. Now, this time I didn't even type out the given for you, just so you could practice if it's not right now. Normally I put it there for you. If there's nothing given in statement 1, you do actually want to write out what is given to you. So I can see that the measure of angle ABC is given to be 2x plus 3. And I usually just write this for you to save you time, but technically if you were creating a proof on your own, you would have to state the given first. We're also given that dBF is, so the measure of angle dBF is 4x minus 101 degrees. The reason for that is just given. It was given to me in the picture. Now, if you want to, you can state that angle ABC and dBF are vertical angles, definition of vertical angles, if you would like to. I won't make you do that because vertical angles are able to be identified visually. So our textbook doesn't make you write that statement. They let you just go straight to saying they are congruent. But if you want to, you could first state that they are vertical angles, definition of vertical angles. But I'm going to go straight to, if they're vertical angles, then we know they are congruent. So I'm going to say that angle ABC is congruent to angle DBF. And if you look back at the theorem, it does say that they are congruent. Okay, so you can't say that they're equal. You have to use the theorem which says they are congruent. And our reason for this would be that vertical angles are congruent. If you would prefer, you can write the vertical angles theorem instead. One or the other, you pick. Most students like this because they can just memorize what it says. Now, eventually we want to set these equal, so we have to go from congruence to an equal sign. So we'll just say the measure of angle ABC is equal to the measure of angle DBF. What allows me to go from a congruence to an equal sign? Congruence to an equal sign. Jeremiah? Good. This would be the definition of congruent angles. Now once you get to the equal sign, we can substitute in the values and then it becomes an algebra proof. So angle ABC is our 2x plus 3. DBF is our 4x minus 101. And again, that's our substitution property. From here on out, it's just solving. Now there is a chance if you solve it a specific way, you may have to add an extra line to your proof to do symmetric. So personally, when I solve this one, I always make sure I put the x on the left so that I don't have to use the symmetric property. So I would probably subtract 4x first. You have to do one step at a time in justifying your proof. You can't also subtract 3 at the same time. You need to do it in 2 steps. So we would get negative 2x plus 3 equals negative 101. Which is our subtraction property. Then we would subtract 3 on both sides. We subtracted, that's a subtraction property. You can have the same reason written twice. And then lastly, we would divide by negative 2. We'll get x equals 52. Now, had you have subtracted 2x up here, you would end up getting 52 equals x, and you would have to add a line 8 to make it x equals 52, symmetric property. So that's why I usually choose to solve it so that the x remains on the left. All right, on the back, we're going to take a look at just some more solving for x and y and finding angle measurements. But we are going to throw in some supplementary and complementary. So when you're doing the problems both today and in your homework, you just always want to identify what type of angles do I see. Do I see vertical, supplementary, or complementary? If they're vertical angles, we know that those are congruent. Therefore, they are equal in measurement. So you will set the expressions equal and solve. If they are supplementary angles, what would you do to solve those? For example, this. These two angles are supplementary. What would you do? Yeah?
Add them together to equal 180.
Good. Add them together and set equal to 180. Because supplementary means the sum addition equals 180. And if they're complementary, we would add the expressions and set equal to 90. Now sometimes they will give you more than one variable, like x and y. So you will have to find the value of each, and then they do want you to find the measure of each labeled angle. So you'll take the variable and plug it back in. So in example 3a, I see two types of angles. I see these two are supplementary, These two are supplementary, and then these are vertical. If you notice that if you were to write an equation with these, you would have 2x plus 2 plus 3y plus 20 equals 180. You can't solve something when you have two different variables. Okay? So you would want to start with the ones that both have y. So we're going to start with our vertical angles, which we know are congruent. Therefore, their measures are equal. So we can set 3y plus 20 equal to 5y minus 16. Go ahead and solve for y. And plug it back in to find the measure of each of these angles. You'll probably want a calculator out to substitute it back in, just to save you some time. But so pretty much everyone getting y equals 18, which is what you should get. When we plug it back in, 3 times 18 plus 20, and 5 times 18 minus 16. Now, some of you may be tempted to only plug it in one, right? On a quiz or test, I would plug it in both just to make sure they're equal, that you didn't solve it wrong. Because if you did somewhere solve it wrong, that will help you catch your mistake. But what is the measure of each of these angles going to be then? What did we get? Noah?
74 degrees.
Good, 74 degrees. It is important that you find this before you solve for x. Now, to solve for x, which you guys are probably going to have to squeeze this down here because there's another problem over here. You need to use the fact that we have supplementary angles. Either these two or these two. And we know supplementary angles have to add to be 180. Now it's up to you whether you actually want to write an equation. 74 plus 2x plus 2 equals 180. Okay? Or if you want to actually find out what's the measure of this angle. What would the measure of this angle be? If this is 74, what would the measure of this angle be? Right? 106. So some students like to actually subtract them, get how big this angle has to be, and then just write 2x plus 2 equals 106. Then solve for x. Okay, so you have that option, or you could also do 74 plus 2x plus 2 equals 180. It's going to get you the same answer whichever way you prefer. Okay, but when we subtract and divide, or whenever we combine our like terms, subtract and divide, we should get x equals 52. So make sure if there are two different variables that you do find the value of both. And then we do have the measure of each angle. This one would also be 106. All right, the next one, we already kind of looked at this one. These together form what's called a linear pair or a straight angle. So we know that these would be supplementary angles, which means that they sum to 180. Sum to 180. So we have to add the two angles together and set equal to 180. So we'll have 3x plus 31 plus 2x minus 6 equals 180. The parentheses are really irrelevant because you have like a positive 1 here. If you distribute a positive 1, nothing changes. So you're just going to go ahead and collect your like terms. See if you guys can solve out for x and then plug it back in to get your angle measurements and verify that they do add to 180. So we should be getting x equals 31. Who can tell me what they got for the obtuse angle? How big was this one? Luke?
124.
Very good, 124, and that's again just plugging in 31, 3 times 31 plus 31. And what was the measure of the acute angle then? Joseph, what did you get for the acute angle?
56.
Good. And then double check those together, we add them together, we do get 180. Okay. Last one then. Find the value of each variable and the measure of each angle. So first of all, notice that this angle is 90 degrees. So if you want, you could add a little right angle symbol. And we notice that we have a straight line here. So if this angle is 90, then these two angles together have to be 90 as well. Which means that these two angles right here are complementary. And we know complementary angles have to sum to 90. So you do a little bit of inferring based on the diagram that these are indeed complementary angles, and complementary angles means that we'll add them together and set equal to 90. Combine our like terms. 3k plus 1k is 4k. Plus 10 equals 90. Subtract and divide. And we'll get k is 20. We do have to plug it back in again. And when they ask you to plug it back in on the homework, like you can just write it in the picture. You don't have to write out like angle AOB equals. Okay, but 3 times 20 would get me 60. 20 plus 10 would get me 30. 60 plus 30 is 90, so I know that's right. Okay. So if you guys can take a look at the closure, just kind of read through it and get some ideas together. We'll go over it after I'm done passing out the homework. All right, so if you remember, we went over the proofs on the front. I said, excuse me, the theorems on the front. I said there's a proof for each theorem, why it exists, but I won't waste your time doing all of them. This is an example of one of the proofs, which is proving the congruent supplements theorem that we learned on the front. So this is actually a proof to show you why they are congruent with any numbers. We showed it with just a sampling 130 and 50 or whatever we showed. But it tells you angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. The first statement then tells me that the measure of 1 plus 2 is 180, and the measure of 3 plus 2 is 180. What do you think allows me to do that? To go from telling you that they're supplementary to telling you that they add to 180. Right?
The definition of supplementary angles.
Good. We went from a word to the number that represents that word. That's the definition of that word. The definition of supplementary angles. And since they had both of them, and it was the same reason, instead of writing definition of supplementary, they just lumped those together in statement 2, which you are allowed to do. Now the big mystery will be, how did they get from here to this statement? We have measure of angle 1 plus 2 equals 180, measure of angle 3 plus 2 equals 180, to say that the measure of angle 1 plus 2 equals 3 plus 2. They went from this to this. Any ideas? I'll give you a hint that it's a property. If you go back to yesterday's, you have your list of all your possible properties, your little word bank. Let me give you a little simpler example. If I told you x equals 2 and y equals 2, and then I told you x equals y, what would allow me to do that? X equals 2, y equals 2, therefore x equals y. What property would allow me to do that? you.
Transitive property.
Close. Transitive would have to be like if x equals 2 and 2 equals y. Since it's not in the right order, it wouldn't be transitive. You'd have to use the symmetric, then the transitive property technically. But close, really close. Substitution. Since x is equal to 2, then wherever we see a 2, we can substitute in an x. Or vice versa, you can substitute in y. That's what they did here. Since 1 plus 2 equals 180 and 3 plus 2 equals 180, what they did was since 3 plus 2 is equal to 180, they substituted it in for 180. So this is the substitution property. This is always the hardest one for students to see. So I'd make sure you draw this. Make sure that the arrow actually is visible. All right, then from step 3 to step 4, what did they do to both sides? They got rid of the measure of angle 2. How? Measure of angle 2 was here, now it's gone. Measure of angle 2 was here, now it's gone. It's a property of equality. What did they technically do? Noah?
Subtraction property of equality.
They subtracted it. We see addition? So they subtracted the measure of angle 2, which when you 2 minus 2 or 2 minus 2 would both cancel out to be 0. So that would be our subtraction property. And then the last step, they went from telling me the measures were equal to saying that they're congruent. What's the reason that we can go either from an equal sign to a congruent sign or from a congruent sign to an equal sign? What allows me to do that? Kayla? Yes, definition of congruent angles. So this proves, since this is supplementary and this is supplementary to this, then the two supplements have to be congruent. Okay. All right, on the homework, make sure you do read the directions. The top 3 just say find x. There are a couple that are what they call paragraph proofs. So instead of having 2 columns, they just kind of like write it all in a paragraph. You're just filling in the blanks. But you'll see some of them will look kind of like what the closure looked like. So kind of use that as a guide. And then some of the other ones ask you to find x and the labeled angles. So you will actually plug those numbers back in.